From the time that I started programming, I've worked on a few different web scraping projects, and actually the first paid project that I had as a programmer was a web scraping project. So it's kind of like the project that I first learned how to build actual programs with and work for clients. Since that time, I've always been really interested in web scraping, and especially after I learned about a company like Diffbot that makes an AI based web scraper. And it's a very profitable business too. And the business model is centered around collecting this data from the web and making that accessible to others, to businesses, or whatever use cases you have. The internet is the largest source of information that we have as human beings. The problem is that most of this data is unstructured. So in order to get the value out of it, we need to not only acquire it, but also structure it in a way that we can use in applications, or even just to query to find meaningful insights out of. I have identified three main parts of every web scraping system or web scraping project. And these three parts are the web crawler. The web crawler is the part of the code that's going to jump from website to website or link to link, like links within a particular domain or base website. The other part is the information download, or resource extraction. So this is extracting the raw information off of the web. This could be HTML pages, but it could also be any of the downloadable resources that are available through these websites, like PDFs or whatever it might be. And then the third step of this is the information cleaning. And this could also be thought of as a separate form of information extraction, where we're going from this highly unstructured data to the more structured data. And each one of these three parts, the crawling, the raw information extraction, and the cleaned information extraction, all of these three things should be treated independently. So these are three main things that I've learned from doing web scraping projects. And one of the things that I've recently been thinking about is the crawling part of this web scraping. I have crawled websites in a number of different ways. Sometimes I might use external tools to just grab all of the links from a website that I am going to need, and then I save these links in a CSV, and then when I go to extract information, I'll read the links from the CSV, something like that. But I've recently been thinking about how is this done, where you give a base URL and then the web crawler just goes out and finds all of the links that are connected to that URL. And you could do the global links, and this would be going from website to website, or the local links, all of the links that are associated with that particular website. So as I said, I've done a number of scraping projects before, but I wanted to build just a general web crawler part of this system. So that's what I did. I built a very minimal web crawler that crawls all of the local links on a base URL. And I did this kind of as an exercise just to see how this could be done. And, from anytime you do something, you learn something. You learn what are some additional approaches to this problem. What are the problems that exist within this problem? By formulating a solution, you gain a deeper understanding of other factors involved in coming up with this solution. So here's what I have. I have it's 40 lines of code here. And two functions. The two main functions are crawl and find local anchors. And local anchors are, you have a base URL, and then you have the paths that are connected to that base URL. And if you took a path and the base URL, that is a URL or link within this website. So the first part of this code, the first function that is called is crawl. And with crawl, you send it a base URL and you give it a start anchor. Okay, and I wrote a test case here where my start URL is MIT OCW, or OpenCourseware, And the start anchor, if I just put it as like the a slash, then it's going to crawl the entire website, all of the links for this website. And within my test case here, I'm just printing out the length of the URLs and the URLs. So I already ran this code. It took a little while to run because I'm not doing like any multi-threading or anything like that. But I found that there are 5,600 links on MIT OCW, and also this program just outputted all of the links here. So it's a long list of links. And while I was scraping it, I was also printing out the links. And if we dive into the crawl part of this program, there's a few steps here for this for the business logic, where I'm only going to crawl the links that do not have a suffix, because if it has a suffix and I go to crawl it, then I'm making a GET request to this resource and I start downloading that resource. And as I mentioned in the beginning, I want to separate out the crawling, the information extraction, and the cleaning. I'm not even touching the cleaning here. So there is some downloading of information in this program, like I'm downloading HTML and then I'm searching through that HTML, but I'm not trying to download all of the resources from this website. Even on a single HTML request, okay? There are a number of additional resources being passed around when I go to any HTML page. For example, there are the network requests that are happening. And I find it useful to collect the network request and not just the HTML that is returned, because sometimes with these dynamic websites, yes, you have some HTML that is returned to the page, but there are also a number of network requests that happen after that HTML is loaded, and sometimes you get more data in that network request, or the data is already structured in a way that it makes the information extraction processing a lot easier rather than having to like go through and parse out HTML. So that's kind of the point here, is that if we create one program that's going to just find all of the different links that are available, then we can somehow pass these links over to the information extraction process, and maybe then we can treat each one of these links differently depending on what type of link it looks like. Like if it's a PDF, then all we need to do is run a GET request and save the resource to some location. But if it's an HTML page, then we probably want to run a GET request, but also save all of the network requests that are happening after we've loaded that HTML page. So this is the first version of this like really simple web crawler that I was just building from scratch as like kind of a practice thing, and I can show how it runs. So if I comment out this start anchor, and then we'll just do this is like a specific course within MIT OCW. So they're going to be far less links than the 5,600 that we got from this /start anchor, but it runs much faster. So we'll run this test case here. So I'm just printing out all of the URLs as we come across them. And at the end, there were 96 URLs returned from this course here. And we can, I actually don't even save all the links here. So there's more to do here. I need to like save the links. But then once we have these links saved, then we can have a different program that's going to go through and download all of them. And then maybe once we download all of them, we can have a separate program that's going to extract the information and clean it up. Like maybe we want all the textual data, and we're going to build a search engine using all of the text-based data in the PDFs. And I wonder if we also got oh no, we didn't get the YouTube URLs because MIT OCW uses YouTube as like its video engine, but we're only getting the local links. So maybe I think I'm gonna add a global link crawler too, and I might, in order to do that, I might just change around this the structure of this code to make it a little bit easier to extend. So that's it for this video here today. Thanks for tuning in. If you like this content, be sure to subscribe, and I'll see you next time.